Hello, my name is Efe and I am a student in the Department of Industrial Engineering. In this video, I will present my physics laboratory experiment titled Determination of the Spring Constant using Dynamic and Static Methods. The objective of this experiment is to determine the spring constant by both static and dynamic approaches and to compare the results obtained from these two methods. In the static method, the spring constant is calculated using force and elongation measurements, while in the dynamic method, it is determined using the period of oscillation. The experimental data were analyzed and compared with the theoretical model. Now, let's move on to the experimental stage in the procedure. So this is my first setup that I worked on. This is for the determination of the spring constant by the dynamic method. I am trying to get 10 oscillations or more, trying to find my period, my t, and I'm going to do calculations based on that. Okay. Now this is my linear fx graph that I gathered from the static method. Now here is my static method data. Now I'm doing some more basic calculations. Now there's a close-up on my setup for the dynamic method. As you can see, I can clearly see my oscillation period, my starting points, and I can gather some clean information out of my setup, thankfully. Now here is my dynamic method data. This one is going to be crucial for finding the K. Now if we go on with our calculations, we find K static 12, roughly 12, based on our slope of the best fit line. Now finding the spring constant for with our dynamic method is not going to be that easy. Our formula here is 4 times p squared times m efficient over t squared. And m efficient, as you can see, is m plus m spring over 3. And if you know our t, the formula gives us 9.5 K dynamic. The percentage difference between those two values was found to be about 23.4%. The difference between those two results kind of comes from experimental issues. In the dynamic method, only one mass was used, which reduced my realness of result. After that, small errors in measuring the oscillation time due to human reaction time, air resistance, and damping effects in the spring may have played parts in my results. Another uncertainty is the approximation made for the effective mass of the spring. But looking on the bright side, the force extension graph obtained from the static measurements showed a very clear linear relationship. This indicates that the spring follows Hooke's law of good. So for this reason, the static result is considered to be more reliable than the dynamic one in my experiment.